Hi, John Anderson. Last year I had a successful and ongoing collaboration in the Explorer Challenge with my colleagues at the Australian Institute for Machine Learning. I introduced the concept of using gravity gradient strings and MT to map mineral systems upwards from 30 kilometres depth. This year I looked at geochemistry in the top kilometre and have enough ideas to make an individual submission. I believe the results have immediate application to more efficient targeting in South Australia and further afield. Allow me to take you through the story.
The submission tests and validates two concepts with the potential to make a step change to targeting across the craton. Firstly, an updated stratotectonic model connects the spectrum of deposits in the Olympic metallurgic event. Secondly, a more reliable geochemical tool for vectoring to targets than preceding pathfinders. A study area was selected for the abundance of IOCGs, drill holes and data, including excellent studies by the state's Geological Survey. One key aspect of the model is the Gawler caldera that formed at the same time as the deposits. The eastern margin of the caldera is shown as the black dashed line on the modified survey plan for the study area. One immediate outcome is the magnetite deposits are in the caldera, whereas the hematite deposits are up on the shoulders of the caldera. The composite plan better shows the second key aspect, and that is a unit in the middle of the GRV that marks the time the caldera and the deposits were formed. Shown in orange, the marker drapes onto the shoulder of the caldera, where maar-like ferruginous sediments and volcanogenic quartz conglomerates collapsed into the IOCG pipes. Gravity gradient strings map the caldera margins and explain the relationship between deposits, structures and conductive pipes mapped with MT. The ZAI geochemical tool originated as an idea at Paris. It is based on the premise that whole rock zirconium and hafnium assays map alteration intensity. Using the 4-acid ICP assays of the survey study, the ZAI tool was tested on the same holes that the survey used to develop their own Pathfinder Prospectivity Index. The ZAI passed with flying colours in a variety of scenarios. ZAI works because the ratio normalises otherwise erratic zirconium and hafnium values, which have a strong correlation in zircon. Despite aggregating multiple pathfinders, the PPI does not provide precise downhole information like ZAI. When combined with the stratotectonic model, ZAI can provide information on the proximity and vector to a deposit nearby. It is like each hole has a unique DNA with a common genetic thread. In this hole, the ZAI reads as proximal to a deposit in a lateral direction, not downwards. ZAI offers a cheaper, simpler and more reliable method of measuring the proximities and vectors to new targets. In this example, only 6 samples are needed at the top of the basement. Having validated the ZAI concept, the study moved to examining holes around the known deposits to establish proximity ratings and templates for target distances. 4 proximity ratings and target ranges were established. Using these criteria, 9 drilled areas with respective proximal ratings are recommended for review. In 5 cases, vectors were determined by additional information, either from adjacent holes, stratotectonic position, or MT anomalies. There is now an opportunity to apply ZAI more widely across the Gawler craton, starting with holes having the requisite 4-acid ICP assays. Where absent, strategic drilling and 4-acid ICP assays are warranted in priority target areas.
I have another geochemical ace up my sleeve for regional targeting. However, I've run out of time, so I invite you to read the Austrike submission for more details. I believe the submission ticks all the competition boxes. It uses government geochemical data to develop an innovative geochemical tool. This will significantly complement geophysical targeting in covered areas and offers a practical numerical pathway for the application of AI. I also make recommendations for the incorporation of the ZAI concept and tool, along with some other ideas in this submission, into the upcoming expansion of Geoscience Australia's EFTF program into South Australia. Cheerio and enjoy the read.